I'm very happy to be here today, and also this is a subject I've stumbled upon not long ago, and I'm eager to share with all of you here. This talk actually came up from a challenge with a project I work on, which has some tables with more than millions of records, so more than 10 million records. So performance was required, and we've had to do some optimizations. And one of the most things we use it are query expressions. So, okay, just some context about me. I am Vanessa. I'm from Recife, Brazil. The red mark to illustrate better, so I've come a long way to be here today. And also, I'm a Django Girls organizer at my hometown, Recife. And I also was part of the first female majority hackathon in my hometown, Hack Girl. And the bold text in blue is my Twitter handle, and I'm going to post the slides there after this talk. And also, if you have any questions, comments, or general feedback, please feel free to reach me there. As I said, I work as a software developer at Vita Software. We are a product consultancy company from Recife, Brazil, which works with our clients mostly from the Bay Area and New York to evolve the products using top-notch UX and development techniques. And we work mostly with Django and React. We also love open source, so we have a lot of tools on GitHub that you can check at github.com/Vita Software. And we've got a playbook as well with all our processes learned so far, so you can check it out on our website. It's pretty cool. So, okay, on to the topic. We're going to talk about query expressions today, but first, I want to ask all a question. Have you ever tried to fetch complex data in an application and got really confused? It's a rhetorical question, almost there, but it's happened a lot to me, so I can only imagine how many times it has happened to all of you here. And as I use Django in my day-to-day, I've thought some time ago that this framework is 14 years old, so a lot of people use it, so it must have something to help me get whatever I want in the best possible way. And I also I've worked with applications that grew large over time, and with changes on business rules and context, it became very common to create some redundancies along the way. And we ended up creating more and more fields in a database than we actually needed. And that's a reality of a lot of systems out there. And to mitigate some problems like this, sometimes people follow paths such as caching or denormalization. And by the way, if you're interested in denormalization, there's a great talk about it by Flávio Juvenal. He's one of Vinta's partners. You can check it out on YouTube. But if your application isn't really complex, it doesn't need the mentioned advanced techniques, you don't have any excuse not to use the ORM and to do your queries, and we're going to learn why and how today. But we can't start talking about query expressions without explaining what the ORM means. This powerful tool called the ORM. As you may know, in Django, we have the ORM, the object relational mapping. And for those who don't know, it's in few words, it's a tool to translate our most of the time relational database dialect into Pythonic objects, named models, so they become more readable and manipulatable. And it has lots of useful things that we can use to search for something in our database. So for example, we have a filter, which we're going to be using a lot today. And as I said, it has lots of abstractions to help to get our data much more easily than writing the pure SQL, sorry. But today, we're not going to talk about simple filters. We're going to talk more about and dive into some concepts about the query expressions, such as Q&F objects, database functions, conditional expressions, and present the many ways in which you can appease your advanced query needs with Python and nothing more. With Django built-ins also. And all of that, we're going to be using query expressions, which are smart yet straightforward functions that can be used to compute values on query execution. So for example, if you want to do queries with OR statements, string manipulations, calculations, and so on, everything at a time Django hits the database, you're going to be using query expressions for that. So this removes the necessity of having extra columns there in our database and helps to generate readable and optimized queries. So for instance, with a sample database of 500,000 records to get people who were born in a leap year, for example, instead of writing the SQL on top, or maybe the naive code on the left, which run, by the way, with an average of almost 4 seconds. We're going to write the code on the right, which run in an average of 0.32 seconds. And for that, we're going to use the query expressions learned today. And to start with them, we're going to understand more. We need to understand more about queue objects. So because they are the most common solution, and if you are familiar with Django, you must have used it a lot. They are usually the first contact one has with complex querying because its API is not too difficult to understand. So they serve as an SQL encapsulator for queries with different conditions. So if you want to do queries with OR statements or negative statements, queue objects are what you're looking for. So to start with a simple example, if we want to fetch people who were born in different generations, by the way, birth date is a field in our person model, we need to change the queue objects like this, passing each one of our conditions into a queue object, and then separating them using the OR operator. And Django is smart enough to generate the SQL and filter everything for us. So in case you want to add more conditions, it's possible to compose complex filters with queue objects as well. So remember our first filter by years? Now we've added a location filter inside a queue object as well. So this will filter by anyone who was born in one of these ranges, range of years, and lives in California. So you can mix queue objects using the operators, the ampersand or the vertical bar. So to include more conditions, you can just add more queue objects and separate them, and it's all good. And just a tip, because it's very extensible, complex filters with queue objects can get huge over time. So, and I know some people say that good code is self-documenting, but it's advised to comment just a little bit so you won't lose time trying to understand the code you wrote a year ago, how it works today. And as I said before, you can add as many filters as you want, such as bullet type, job, as I did here. And so moving on, let's say that our application has an interface that users can search stuff. And the user can input whatever they want, and we're going to search for all possible fields using insensitive contains, for example, the lookup. And that will work, but what if the user wants to search just for the first name, for example, or a job title? We can give our user the freedom to search for whatever things they want. And that's possible if we mount a queue object before doing the query by using an approach with some ifs in queue.add. There are some other approaches, but I've chosen this one. So it will check which fields the user has selected, for example, in our filter, the UI, and add conditionals accordingly. So for example, a male field was not included in the search, so it won't be added to our final filter. And at the end, you're just going to pass the mounted filter, the mounted queue object, to the ORM filter, and it's going to work. It's going to find, for example, people with Mark as name, first or last, people which work as a chief marketing officer, trademark attorney, and so on. And just a quick off-topic, if you are more familiar with SQL and want to see what your database reads, you can print your query with .query, the yellow arrow, and you're going to see the output below. In this case, for Postgres databases, I've omitted some info just for simplification as well. If you also want to format it, you can use a lib called SQL parse. It's a Django dependency, so it already comes when you install Django. The point is that it's important to understand that at the end, everything's SQL. It took me some time to realize that. And as you can see, Django handles everything for us, so we don't have to worry about writing super long SQL statements, which is not quite the case now, since we have a very simple example, but that becomes a reality once your application scales. Another base resource which is very useful for queries is called F expressions or F objects. And to start with it, I want to show an example first. According to the American Red Cross, people can donate blood every 56 days. So we have our person model here that you already know about, with your fields, last donated and can donate on. And theoretically speaking, when last donated gets updated, we should update the can donate on as well, with 56 days ahead. If you want to get people who can already donate, you could do something like this using filter. The list then or equal today's date. But what happens if the last donated field is updated but can't donate on is not for any reason? It's critical because we can guarantee that this field is going to have a reliable value. And it's also critical because we can let people donate blood before the 56 days. So this code could cause serious inconsistencies. And to solve this problem, you will have to use F objects because the value would always be calculated at query execution. So it will always be correct. And F objects are used when you want to reference model fields or reference annotations without having to load the values into memory. So you can do basic arithmetic operations on query execution. For example, as I said, people can donate blood every 56 days. So to know when they can donate again, you can annotate the date using F to get a last donated value and add 56 days using time delta, for example. And without it, you would have to write the raw SQL because or filter with Python, which we saw in the beginning of the talk, decreases performance a lot. Because there's no such way to do operations like this in an effective way without using F, as far as I know. So we can also use F to do operations with different fields or to reference annotations, as I said. So from our last example, we annotated the exact date in which people can donate blood again using F and time delta. But now we're going to use F for everything. In this example, we run a blood bank and want to check how many bags are missing for our goal. And to do that, we can use an annotation of how many blood bags we currently have in our bank and subtract this value using F from the goal quantity, which is a field in our blood bank model. So we're going to get exactly how many bags we are missing from our goal, 500 in this case. So in the previous example, we've used F with two fields, but both were integers. So in case we want to do operations with different fields, with fields of different types, I mean, we have to use something called expression wrapper. Because when you try to, for example, in our event model, sum the event duration with the starts, the ends on, the start at, sorry, Django is gonna throw field error because it's a duration field and a datetime field, different types. So that's solved by wrapping our sum in an expression wrapper, in something called expression wrapper, and setting the output field as a datetime field. And Django is gonna be smart enough to do the operation and give the result to us in a datetime field. So for example, if we have an event that starts today and has a duration of 1 day, the ends on should be tomorrow, same time. And at the end, we can mix F and Q objects all together to create unique queries. In this case, we want to get people whose first name equals their last name and don't have mark in their job titles. I have nothing against marks, it's just an example. And as you can see, query expressions are very modular, just like other resources we're going to see soon. We've seen how to create filters, how to access and do operations with different fields, and now we're going to learn and use how to manipulate data with database functions. There are basically some abstractions to help us to get our database, to access database level functions, as the name suggests, directly. So for example, to count how many pets we have in our system, how many pet types, I mean, we have to use a function called count in an annotation. And that, just like most of the database functions, is going to be available using the field you pass, the name of the field you pass, under the database function name. So in our case, we have type under count, so that at the end we have the distribution of pet types easily. And there are more than 50 database database functions. And so I won't show them all today because of the time, but we're going to see some of them and see how useful they are. Database functions used with annotations are very important resource, especially when performance is needed. So another good example, we have our person model here, and it has two fields, first name and last name. And I want to search for a string in their full name, so adding a property would do the trick. I just have to load every person into memory and do the search. But there's a problem here. Since it's a property, it cannot be used in queries. So if I want to search, do a search in everybody's name, in this scenario, I will have to load everyone into memory. That's not what I want. And a solution to that relies on an null function called concat, which stands for concatenation. So you can annotate the full name by calling this function with the field names. By the way, I had to put a value there because Django, if I had just put the empty string, Django would try to look for a field name at empty string, and it will throw an error. And after annotating the full name, I can use as many strings lookups as I want, and it's going to work. Just so you see, I wanted to bring this GIF just to compare our solutions with the full name property and the annotation. So at first, it's very fast, but as I add more zeros to my limit, the worse it gets. So the last frame was like 500,000 records and took about 4 seconds to load everyone's full name. And in a big application such as the one I work on with millions of records, that's too long for the end user, and we cannot let things like this happen. And back with our full name example, here's a tip. To avoid calling the whole annotation and importing everything every time you want to load everyone's full name, you can add this annotation to a query set or a manager. I pick a query set just for simplification. And add the query set to the model using as manager. So now you don't have to worry about it. Whenever you have the person model, you can just call annotate the full name, annotate full name method, and it's going to work. And then you can do the search just like as you want. And another great example is a database function called Colley. It returns the first no-null value given at least 2 field names. For example, our person model has a nickname field, and if they have one, I want to show it. And if they don't, I want to just show the first name. And that works, but there's a pitfall. As I said, Colley returns the first no-null value. If anyone has, for some reason, an empty string as a nickname, the annotation will return an empty string. That's not what I want. And a solution to that is using another database function called NoLeaf, added in Django 2.2, which accepts 2 expressions and returns none if they are equal. So in our case, we compare our field nickname with an empty string value. And again, I had to use the value function, because if I hadn't, Django would look for a field called empty string. And that's going to work. We've seen that we can do some conditional queries with NoLeaf, for example, in our last example. But if we want to do some complex queries with just one turn, we can use conditional expressions. So they allow you to use conditional logic in queries. That means filters, updates, annotations, and such things. And without them, you would have to use Python, and the code would be bigger. So for our example, let's say that people can order things for some marketplace, commerce, and let's give them discount if these orders, if they are to this order, if they are loyal customers. So using the orders for today, let's get if the user joined our system this decade. In this case, we're going to give them a 20% discount. In case they joined between 2000 and 1995, we're going to give them 40% discount, and so on. So, by the way, it's 0.8 and 0.6 because the discount is subtracted from the full price. And we can understand this code, but it's not really too easy to read. A better way to do it would be using case and when expressions. So case is very useful because you can use like ifs, ellipse, and else's in your query in little to no time. And it's better because the value is calculated at the time the query it's executed. So it will be much faster. And if you want, you can also filter the result at database level, so you hit it only once. So, and as it's an annotation, we don't lose the original order total. And at the end, we can mix everything we learned to annotate if someone's birth year is a leap year, for example. So just to give some context about how to calculate a leap year, it's very difficult. It took me some time to understand. It should be exactly divisible by 4. If it can be exactly divisible by 100, it's not unless it's exactly divisible by 400. It's a bit tricky, but just to get the idea. So we start by doing the needed annotations with database functions, cast, to transform the value from extract year to an integer, because extract year at database level returns a double precision floating point that I don't know about it. I've never personally used that as well, but that's what the error said. Enough objects to do the operations with reference annotations to get the modulus of the integer, for example. And then we use the previous annotations into a conditional expressions with kill objects. In the when second line, we define false by default, and we can do all the math to make it true. And finally, we filter by the annotation we just did. And from now on, it's just testing if we did the right thing. So at the end, we have done calculations in conditionals, just hitting the database once. It's pretty amazing. And these are the references that helping me, inspiring me to do this talk. It has the links that I'm gonna post. I'm gonna post the slides on the Twitter. You're gonna check it out there. And that's it. Thank you.
Thank you, Vanessa, for your talk. It was very interesting. To confirm, it appears that Q objects can handle nested parentheses. If this is the case, have you used Q objects to create complex filters inside a DRF? Theoretically, this would allow complex filtering on the API endpoints. Thanks again.
Thank you. Sorry, can you repeat? I just...
Okay. Can you confirm that the Q object can handle nested parentheses? So a group inside of a group, for example.
Yeah, it can.
Okay.
You can debug this with the .query if you want to see the SQL, the output.
Okay, that's cool. Now, the second part, have you used Q objects using Django REST framework?
Yeah, but I'm not too proficient with that. But I've used it, but it works normally, just as I'm using Django.
Okay.
If you have any specific scenario, we can talk after.
That sounds good.
Okay.
Thanks again.
Thank you.
I have a question about the extract here doesn't return an integer. Do you know if it's in all databases like Postgres, MySQL, and whatever else exists?
Are you talking about the flow, the double?
Yes.
I'm not sure.
Okay.
I'm not sure. I've used Postgres for to make these examples, but I think that MySQL works the same way.
Okay. It seems kind of weird. To return
Yeah,
a double.
exactly.
All right. Do we have any others? No. Okay. In which case, can we thank Vanessa once again?
Thank you.